Okay, so 2-1. The whole chapter is on graphs and functions, but we're going to start very, very, very basic today and talk about the coordinate plane. So, same coordinate plane we've used since we were in pre-algebra. You've got your x-axis, which is horizontal, the y-axis, which is vertical. The origin is that middle guy, 0, 0. The quadrants start at 1 at the top left, and they go, or top right, I'm sorry, and they go left counterclockwise when you're numbering them. We all good with that? Do I need to give you time to write that down? Okay. I'm going to go ahead and plot these for you because I know you don't want to. So P is negative 2, 2. We're all good. X comes first, then Y. If there's a 0, then you have either an X or a Y intercept if you have a function. It's on the axis there. Everyone is good. We know how to plot. We're in college algebra. Okay, happy. We know how to plot. I'm going to take away this because Desmos, and you guys might know how to do Desmos, but I don't. So, if I'm going to graph the, let's say, the years and the deaths. So let's just kind of hide this this column. We're not going to worry about this column. Okay. So if I'm going to do that, what should I make my x-axis? What should I start with? What should I count by? Should we start at 0? No. Cameron? Okay, the x-axis is going to be the years.
Oh, 1940? 1950.
Okay, we can do 1950. We can start with 1940. You don't want to start with 0, though, right? So we're going to do a little jagged line saying that we're not starting at 0. And I don't care whether you start at 1950. I'm going to go ahead and just, for sake of making my graph a little neater, handwritten and whatnot, we're going to do the years after 1900. And we're going to count by 5. That makes sense? Okay. And then the deaths, we're going to start, again, not at 0. Where would we start? Maybe at 8?
8.5.
Okay. So 8.5. I'm going to be crazy and start at 8.4. Why am I going to start at 8.4? Not that 8.5 is wrong.
So you can increase by 0.2.
Yeah, I'm going to go up by 0.2 and a little easier, a little bit less numbers here. So there's 8.6, 8.8, 9, 9.2, 4, 6, 8, 10. Okay? And then we're going to plot our points. So we're just going to do a basic line graph here. So in 1950 we were at 9.6. 1955 we're at 9.3. And I know you guys all know how to do this. I'm not going to take too much of your life explaining it. 65 is 9.4. And we could do different graphs, right? We could do a scatter plot and do a line of best fit. Or we could do even a bar graph to show these. But if we do this basic line graph, then we're just showing the change in the heights as the time went by. Okay? And we can label our x and y axis as well. We good? Everyone's happy. All right. Distance. So this is where we're going to actually get to calculations. So I've got 2 points, -2, -2, and 2, 6. And I want to find the distance between them. So because I have a graph, and it's just going to be easy for me, I am going to draw a right triangle. And I'm going to count the blocks. So there's 4 for my horizontal distance, and this is 8. And what formula can I use to find the hypotenuse there? Pythagorean theorem. So my A is going to be 4, my B is 8, and I'm looking at, I think my board needs. We're looking at the distance squared. So that's 16 and 64. That gives me 80. And then, of course, you have to take the square root to actually find the distance. Without your calculator, we can estimate the square root of 80 as a decimal.
Oh, I was going to simplify the radical.
Hold that train.
8.9.
8.9? Because 81 is 9 squared, right? So that's a real good estimate. So this is approximately 8.9. But we do need to know how to simplify the radical. So how do we do that?
You would take out the largest perfect square,
Which is what?
16.
Good.
And then you would simplify the square root of 16 to 4.
Beautiful. Okay, so there's two different possible answers. And on Math Excel, please pay attention. In the blue, it'll say as a simplified radical or as an approximation to the nearest tenth or whatever. Pay attention because you're going to frustrate yourself to no end if you're not paying attention. So it was nice. I had a graph. I could do that. If I don't have a graph, how can I get that 4 and that 8? Just by looking at the 2 points. How do you think the 4?
Use the distance formula.
What if I don't want to use the distance formula? I want to use the Pythagorean theorem. How am I getting the 4?
To get from -2 to 2, you have to equal.
That's the distance between the x values, yes? And the distance between the y's values is the 8, correct? How do you get distance between two numbers?
Absolute value.
Yeah, you subtract them and it's an absolute value, correct? So, as you said, we could use the distance formula, but that's the same thing we already did. When we found this, yeah, we have the graph so we could count it, but we are technically subtracting these two x values. And we're subtracting the y values of these 2 points. Okay? So the distance formula is great. We all love it, but that's the Pythagorean theorem. It's the same thing. Okay? But here you have to remember something. And here you can figure out something and understand the distance. Okay? So I want you to be able to do it this way, because there's mistakes that happen with this formula, and you're not going to be given the formula. So that's just one more thing you have to memorize. Okay? So let's try this. And I don't care if you want to use that formula and you know it, you love it, you just sort of listen, I'm one new formula, do it. But there's little things that happen with that formula. Do not touch your calculators. Try this without the calculator. Think about how far apart are my x values. So you're going to find that little distance to be your A number, and you're going to find the y distance to be your y or your B number, and then you're going to do the Pythagorean theorem. What's my x distance?
8.
8. And what is my y distance?
6.
Good. If I add those together, I get 100, 64, and 36 in the square root. Show all of our work here. So you get 10. Everyone get 10? Okay? We're all good. The reason why I don't like using the distance formula, if I do the subtracting, I do 3 minus a negative 5 squared plus negative 4 minus 2 squared. And you guys are like, oh, that's 8 squared. Same thing we got. And that's negative 6 squared. And a lot of you guys will then immediately pick up your calculator, even though you know these numbers, right? What's negative 6 squared? What's a calculator? I did it. You did. What'd you get?
36.
Did you get 36? You get negative 36.
Well,
What'd your calculator tell you, though, is what I'm saying.
well, it was negative 36 by these parentheses, so.
Right. But most of the time you guys are quickly doing that calculator. And I'm not talking, you guys probably do not make that mistake as much as other kids do. But it's a mistake that happens. When you see what you calculate, you just automatically put 8 squared plus negative 6 squared, and you don't catch that mistake. You understand? And that's why your distance is going to be off. So do it mentally. Okay? Without touch. I don't care if it's this way or this way, do it mentally. It's just like he typed it in and was like, that can't be right because it's negative 6. Okay? All right. Figure out if these 3 points make a scalene, isosceles, or equilateral triangle. So you have not 1, not 2, but 3 distances to find. Okay? 3 distances to find, and then we're going to compare them. Okay, what's our DE distance? Square root of what? Okay.
Square root of 68.
Square root of 68. So we had, what's our A?
Square.
Good. That's 2 squared. All right, and our EF distance is 3 squared plus 5 squared, which is the square root of 34. And our DF distance was 5 squared plus 3 squared. Isn't that the same thing as 3 squared plus 5 squared? Right. So we didn't even have to do the adding. We could have just shown this and said I can see, right? But this is an isosceles, yes? Two sides look the same? Okay. You don't have to break it down because they were just asking you what triangle is. Okay. Easy enough. So if they ask you what kind of triangle, 3 distances you have to find. All right. What does collinear mean? Who remembers what collinear means? It's like a geometry term you haven't had for a couple years.
2 points on the same line.
Very good. It means they're on the same line. 2 or more points, right? So to tell if 3 points are on the same line, you can picture this. D, E, F. That means this distance plus this distance would equal this distance, yes? Or, one of whatever. We're not sure. These are the same points, so let's write the distances down that we had. DE equaled the square root of 68. EF equaled the square root of 34. And EF equaled the square root of 34. So my question is, you can tell these 2 are the smaller ones. If you add the 2 little guys up, this makes a big guy. So the square root of 34 plus the square root of 34 equals the square root of 68. Yes? Yes? Or no? What do you guys think? Let's take a vote. Yes? No? I don't know. Not sure. Okay, let's look at it. What's the square root of 34? Let's estimate. The square root of 34 is 5 point something. Okay? What's the square root of 34 again? 5 point something. So the left side equals 10 point something. What's the square root of 68? 8 point something. Okay? Very common mistake. You do not add things under radicals. You cannot add radicals. Okay? To add radicals, the radicals have to be the same. So this left side actually equals 2 square roots of 34, because I have 2 times the square root of 34. The right side, if I simplify it, ends up being 2 times the square root of 17, because this is 4 times 17. Okay, so they're not equal. But it's a very easy thing to say, oh yeah, you're going to add them together, they're going to be equal. So always estimate in your head. You're going, that's not possible. Okay? So it's a trick. Not equal. All right. Find x such that x7 is 5 units away from 5, 4. So you're going to find, we're saying the distance between x7 and 5, 4 is 7 units. I'm sorry, it's 5 units. Okay, so let's do our distance. What's the distance between the x's? I don't know. Let's write this, 5 minus x squared. I do not know. So we're going to just show the subtraction like the distance formula tells you to. What's the distance between the y's? 3. Square squared equals, and they're telling you the distance is 5. And you square it. Okay? There's no need to do the square root because it's going to square both sides and whatnot. Leave this guy in parentheses squared. Leave him alone for a minute. You could expand that binomial, but there's no need to. That's more work than what you want to do. Okay? So what are we going to do now? I don't want to expand the binomial. Subtract 9. Yeah. So we're going to have 5 minus x squared equals 16. Again, we're not going to expand the binomial. We don't need to. What can we do now? Square root of both sides. So if I take the square root of this side and this side, I get 5 minus x equals, what's it equal? 4. It also equals -4. So anytime you're in an equation and you're solving and you take the square root, you need to consider both cases, +4 and -4. Because understand, this point is 5 units from the other point. It could be this way or this way. All right? So we are going to just do 2 separate little equations. You can kind of do it at once if you want, but I get -x equals -9, so x can equal 9. Or -x equals, that side's -1. 1, this is equals to -9. Awesome. You have 2 possibilities. (1,7) or (9,7). Okay, both of those points are 5 units away. All right, so do plus minus if you're taking the square root in an equation. If I just say, hey, what's the square root of 16, you're going to tell me 4. But when you're solving an equation, you're going to get 2 answers. Okay? We good? All right. Let's try another one. Find a point on the y-axis that's equidistant from -3, 0, and 4, 7. Okay. So they're telling you the point you're looking at is on the y-axis. So don't you have part of that point already? What's that point? The x has to be a what? 0. And let's just make the y a y, because we don't know what it is. Okay? So on this side, what's the distance between those x's? 3. And what's the distance between those y's? Y, right? Because between 0 and any number is going to be that number. So think you just subtract in your head, y minus 0 is still y. Okay? So that's the left side. Right side, what's the distance between those x's? Between 0 and 4, how far apart? 4. And the distance between these y's you cannot actually find, so you're going to write it as y minus 7. Okay? Everyone understand where I'm getting at? Okay, now it's cleaned up a little bit. So this side is 9 plus y squared. This side is 16 plus. You do, in this case, have to expand this binomial. Now, if you can do this in your head, because you know the little rule, spectacular. If you have to write it out, I don't care, that's fine. But remember, it's not just y squared plus 49. There has to be middle terms there. It's a binomial squared. So it's going to be y squared minus 7y minus 7y. So this outside and inside have to go together to give you that negative 14y. Okay, and then plus 49. So we have a y squared on both sides. It's going to cancel. we're going to put the 16 and the 49 together to get 65. And then move your 65 over to the left side. So it's just that expanding you got to remember to do. But you can do that in the simplified, how far apart are the x's, how far apart are the y's, in your head kind of thing. Okay? Makes sense? So those last two examples is the hardest it's going to get on this homework. Okay? And then last slide, easy breezy, we good? Is midpoint formula. So if you remember the midpoint formula, it is simply add the two x's, divide by 2, add the two y's, divide by 2. That's the point that's in the middle. That's the average of the 2 points. So we have 5 plus 6 divided by 2, negative 2, and a negative 1 divided by 2. And remember, you're looking at Math Excel. So make sure you're looking at how they want the answer. Do they want it as decimal, or do they want it as a fraction? Or if they don't say, they don't care. Okay? That is it for 2.1. Okay, your homework I don't believe is due until Monday night. That rules the time.